sometimes of its own kind and sometimes of other kinds. So if you have a cluster, what it really enables is some host objects within that cluster, to use a VMware term, to interact with each other. What is the nature of interaction? They do a lot of emotion. There's a lot of things moving back and forth between these two, right? So understanding these interactions is important. Consumptions will not necessarily give you that texture of what the interactions are. They'll just tell you it's doing a lot of networking, or it has a high CPU. Those are all useful. Not to diminish that, they're useful, but they are necessary but not sufficient. So this is where we do our, if you like, what I call our alerting and profiling. And the last thing, which you know, I mean, it's everybody talks about it, but we need to talk about it more urgently because we are taking on interactions, because we are taking on cross-silo, because we are taking on live and continuous. We will have many, many, many more things to deal with in any given second. Okay, the nature of our implementation is such that we literally have maybe a microsecond to 10 microseconds to deal with each single piece of information relating to a consumption or an interaction, okay, to scale, right? So you have systems where you can have 100,000 objects going to 1 million metrics and interactions. And you know, we come and say it's live and continuous. We can't abandon that at that point. So we have to deal with that kind of scale while not compromising any of these, right? So that's part of our architectural challenge. Just to give you an example, the demo that you're going to see is a fairly, no disrespect to Nathaniel, but it's a fairly small system, right? It has about, I think, 250 objects, the last I looked, virtual machines and physical IPs. It has about 4-5 hosts. It has about 20 data stores, if I'm not mistaken. And it has about 40 port groups, some of which were just created for just the fun of it, I think. You know, because, hey, I wonder how this works, and they created a port group and they never used it. And 10 of these, 10 interfaces. You know, if you multiply each of those by anywhere from 10 to 20 is the number of consumption metrics we'll use, right? So if I have 200 objects, and I multiply it by 20, that's about 4,000 consumptions per second, right? You could argue not all 4,000 change, that we don't get information on all 4,000 metrics every second, but it turns out that about 75% of the metrics are available to us every second, okay? So this is just consumption. Go to interaction. These 200 objects can interact with any of these 200 objects themselves. They can interact with the 20 data stores I talked about. They can interact with the 40 port groups I talked about. They can interact with the 10 physical interfaces I talked about. They can interact with the 4 hosts I talked about. And while it is maybe a stretch to multiply these to calculate the number of interactions, the number of interactions is in between 200 and 200 times 4, 200 times 200, 200 times 20, 200 times 40, 200 times 10. So it's effectively a potentially, in worst case, a quadratic effect. Normally, it's not quadratic enough. It's closer to, you know, something which is superlinear, right? So you have 200 objects. Like in this system, each object typically has, on average, about 2 interactions, right? So instead of 200, you have 400 interactions for these kinds of objects. Data stores typically have 10 interactions. So you have, instead of 20 data stores, you have 200 interactions. So if you do the numbers, what you end up with is you have 4,000 consumptions per second, but you have more in the order of 10,000 interactions per second. And this is a small system, right? So you're really dealing with about, let's say, 10 to 15,000 things to deal with per second. Not quite microsecond, but certainly not millisecond. So how do we do this? One of the things, I mean, I don't want to get into the details of this. How am I doing for time?
That'd be fine. I think there was, do you have a question?
Yeah, on interactions, I see you collect stuff from storage, networking, servers, and endpoints. Do you collect VMCI data? Do you collect vApp interactions that happen outside? Do you collect VIX data? Do you collect the SDK data? Because there's multiple ways I can interact with a VM that are not related to a network, they're not related to storage.
No, I understand. So what we collect is, I mean, this is not a closed system in the sense that the data that we're collecting is not sort of, well, this is it, guys. We're not going to change this anymore. So we will add to it. So it's extensible in that sense. But to answer your question, what we're interested in is a VM representing a piece of an application, its behavior.
But if I get interacted with by VIX, I could change its behavior radically.
Yeah, you can.
And if the application uses VMCI as its interconnect, you will never see network traffic, or it could use both.
No, absolutely. So you can have things which have no network traffic, and visibility of the kinds of things you're doing you have to deal with the feeds that identify whatever it is that you're doing. So if you're saying there are...
Whoa. Jeez.
If there are...
That's just how
you guys do more than one mic.
Well, we did set off the fire alarm at Symantec, so...
This is an example of a symptom. It's a consumptive symptom. We have to tell what the interaction is that caused that.
Is that an interaction right there?
There's some interaction which caused it, It could have interacted with us if it had fallen on one of us, which would have been painful. To answer your question, there are blind spots in any system, and the blind spots are defined by the coverage we get with the feeds we have. If somebody is saying we are interested in a completely different kind of information about a VM, then we have to get those feeds and accommodate those feeds. What we drive this by is we talk to our customers, we ask our customers, what kind of information they want about their world. And this is work in progress in the sense that it's an extensible set, but we expect to cover more and more as we move forward, not only in terms of new kinds of feeds, but also diversity in each.
So I'm not even sure how you collect those, that's why I was asking.
Well,
those ones are kind of hard to collect.
No, if they're hard to collect, we're not going to collect them, right? We can't divine it. We're not going to collect them. So if something is insulated and it's not available, we're going to be blind to it. But the point is, any management is only as good as the data it collects, the quality of data it collects, and what it does with it. So just talking about how we do this, and I'll kind of close with that, is traditional management has tended to be sort of focused on, let me get the information, let me store it. First thing I'll do is I'll store it. I don't want to lose it, and then I'll crunch the information. So it's a very data intensive, typically, not always, typically database driven analysis, right? So you can get reports, you can get visualization, but the database is a big part. The way we do it is we think of the database as something which we need to put information in for reporting, but we actually absorb this information into memory, into RAM/cache, and we crunch it, and we manage literally thousands to millions of objects organized in different ways, like trees, and pruning them and keeping them in check so that we can provide information to the UI. We can provide alarms. So every metric that comes in is checked if there's an alarm condition that it initiates, and the thresholds for both interaction and consumption is self-calculated. You can override it, but we calculate it ourselves. So when there's a recording that I think you will see, the information for recording has to be given by this collation engine. Similarly, the alerting, and so you have alerting, you have information for the UI. You also have data that you want to store in the database for reports that people want to see down the road. That data is also used in things like, if you want to get into capacity planning and stuff like that, we can use that data because it's a very rich, high granularity data that we can use in a predictive way rather than retrospectively.
Can I ask, out of the 4 areas you identified that you've got to collect on, which one would you say you are strongest in terms of collecting and analyzing?
Well, I don't know whether I would. I'd like to rephrase that question if I may.
Sure.
So I would say that we have spent the most time of our lives with the network side of things.
Yeah, because when I first looked at Xangati, really it was just networking.
Yeah, but I think we have, I would say in the past 18 months, we really are at a place where you'll find value from our product, even if you shut off any one of these guys. Okay. Now, can we do a better job? Absolutely. How do we do a better job? I think a lot of it depends on the richness of information that we can get, and different environments will provide different kinds of information. Certain hypervisors will be much more forthcoming to providing information. Some hypervisors are very reluctant. Management is an afterthought in their design. I mean, nothing wrong with it, but there's just, they design it to work, and to tell others how it's working is not something that takes primacy for them.
When I first came across Xangati, VMware were using you internally in the lab environment for VMworld, specifically at VDI. I think VMware are now doing a lot of work with VC Operations Manager to add enlightens to it, so you can see view data there. Does that sort of step on your territory a little bit?
It's certainly encouraging to see them pay respect to this live and continuous. But I think it is a very piecemeal specific thing that they're doing, which is Teradici offers APIs to give you information about PC over IP and the quality of information. So they are rendering that information. But it is not, if you look at the way we do it, it's really completely integrated into how we view everything. So it's just one more live and continuous feed, whereas I think other systems like VCOps, they still have a fine-grained photograph to fine-grained photograph mode rather than a continuous video. That's my kind of view on that.
Okay.
Where's David?
What's that? Oh, I'm over here.
You're a blogger now?
What's that?
You're a blogger.
He's gone over to the other side.
Yeah, he heard, said, I'm going to write about this guy.
Stuck up half of it, it's scruffy, criteria for a blogger.
Anything?
Well, yeah, I would, as we get into the demo, frankly, one of the things that hopefully Jagan's talked about, and you'll see this more so in the product, is, architecturally, we're to the question about VC operations, we're looking at fundamentally 2 different problem spaces. Our architecture really started from the performance management domain, and as you can see, some of the things that are absolutely essential on the performance side are the liveness of the system. Customers, hands-on guys like yourself would say, I need to know what's going on now. Live and continuously, I need to navigate through my infrastructure. It's worth noting, Jagan was doing some of that math, but architecturally, the system can process over 1 million metrics a second in the, multiples of that in terms of interactions, which is what Xangati does. Architecturally, vCenter operations can look at 1 million metrics over a 5-minute interval. That's kind of their architectural ceiling.
Not really.
Well, there's settings on that in the system.
No, they set the data down every 5 minutes, but they get every second of that data.
Okay, but
and they don't aggregate That's vCenter aggregates and rolls up. VCOps does not roll up anything until like a year later.
Okay. Well, in terms of, again, when you take a look at the system, what I'll say is that customers who deploy us and have looked at and actually see it as very complementary, right? Mm-hmm. Is that we're a live performance management solution that tends to be more of a longer term trending solution. So architecturally, they were looking at predictive trends, whereas we are coming at things from a performance standpoint. I guess kind of proofs in the pudding as you take a look at things, but yeah,
I think the only point I'd make is I think to me it was a subtle point. Liveness is what you need to do triage. If you want to do post-mortem, you don't have to be live. And I think management systems, and this is not against any particular one or for a particular one, management systems have to get to a point where people are able to see what is going wrong as it's going wrong so that they have a chance to fix it.
Absolutely.
And if you leave it even for a few minutes later, the patient is dead. Okay? Some patients, not all patients die, but some patients die. And
it is analogy.
No. So what you end up doing is a post-mortem. Okay? And I mean, this is the challenge for performance management, whether it's Xangati or anybody else.
Well, the biggest thing is that regardless of how you look at it, it's always after the fact.
It is, but if you can save the patient, that's why I use the medical analogy, because
I mean, no matter when you look at the screen,
yeah,
you may get alerted like 1 second after, but the time you get to look at it, it'll be a couple of minutes
sure,
after
no,
anyway. So
sure. No, that's why I brought the analogy.
You're talking about 3 minutes versus 4 minutes.
No, but this is why medical analogy is important, because there they'll tell you looking at it live is much more important than looking at it 5 minutes later.
Yeah, but not everybody sits around and looks at a dashboard every second of the day.
Okay, gotcha.
Well, yeah, if there's a problem going on there, you are, right?
Or not, because you may not know there's a problem going on. And there could be. There's a problem, but you don't know it, so you're not looking.
Well, if you don't know it, it's not really a problem.
Well, actually,
I mean, just wait for the phone to ring.
Yeah, and this is ultimately where when Nathaniel does a bit of a demonstration, we don't expect people to sit in front of a dashboard all day. That's where the alert reporting is going to play. Is that coming back to connecting all these dots is not only having live information, it's actually having the interactions that were there in a recording that's encapsulated at the time that there's a problem.
Exactly.
Right?
That's ideally what you do.
Yeah, and so I know I think we're kind of transitioning between Jagan's section here almost into let's kind of get you guys hands-on with the product. I know are we still having challenges with the online video feed, or
We're having challenges with the whole network stuff.
Okay. Oh, really?
Yeah, Ethernet summit points.
Okay.
It's always the
So, right now, are we talking to the online audience?
Yes.
Okay. And can you see Roger's screen?
I believe I can.
Okay.
Can you move your mouse around, Roger?
Great.
Yeah, I see that.
Okay.
Very good. Well, what we thought we'd do is instead of me just doing a demonstration for you, and like you all evaluating whether or not I can drive our system, we thought it'd be a whole lot more fun if you guys did your own demo for yourselves. So if you take one of these and pass it down, it's got the information that you need to log into to a Xangati system that's identical to the one that I'll be driving. And you can get there either by the host name or the IP address. The main thing I want to call your attention to is when you log in, there's a little checkbox here that says access through a firewall. So when you get there, you're going to be looking for that checkbox to access through a firewall. And that'll be the handful of magic beans that you need to use to log in. So as you get there, you're going to check that box and hit login. And then you'll use the credential that's on there. It'll fire off a little bit of Java for you, and that will actually load up our system. If anybody's having challenges, just let somebody know. There's plenty of us in the room that should be able to help you get there and get in. So I'll give everybody a second to kind of catch up. And what should happen is that you will end up in a dashboard that looks something like this.
Yeah, I haven't heard you complain about the certificate.
Yes, there will be certificate warnings.
And everybody's going to hit ignore, right?
Yes,
So I would like to see the key. I don't hit ignore on any certificate. Seriously.
Okay, look on his screen.
It's a bad practice.
Fair enough. Fair enough. You can imagine that for my internal lab, though, not so much about getting real certs, right? It changes all the time. So
Look at the issue too.
Took that little thing there.
Oh, there we go.
Look at that little thing right there.
very cool. How are we doing?
Downloading application.
Downloading application. All right. Very good. Well, while that happens, I'm just going to talk a little bit about what you're looking at. Everybody here is used to doing 2 or 3 things at once. So the Xangati dashboard that you're going to look at, as Jagan mentioned, it's really purpose-built around providing a continuous point of view into the infrastructure. Now, this particular infrastructure, as Jagan kind of told you, is actually my marketing lab. So it's a fairly small environment relative to the ones that some of you guys are running. There's, as you can see, there's like 5 hosts in here. I happen to, like when you log in, you're going to get what's called our Vdi Dashboard. So it's going to look at the desktop part of my infrastructure. And that's what should start to pop up for you. Still downloading.
Is the network really slow? I guess it is. Network slow.
Associated with this user.
It's so
They're trying to figure it out. It works out.
Oh, really?
We talked to them.
Okay.
They're aware that there are issues.
So given the Wi-Fi,
probably
the guys here
I'm getting some strange error message.
Yeah.
There is no object associated with this user.
Oh, you press. Let's go back to the login page. You're logging into a different viewer. Where's the HTML page?
You click the wrong
This
button.
one here.
I need to go to the first one.
Yes.
Yeah.
So I should quit that other thing then?
Yes. You can quit.
He's only learning. It's okay.
Click the wrong login button.
How long is the download?
Normally it takes seconds.
You guys are on
Still
the
finished.
meeting room? Meeting room or owners?
But if we get it somehow it's canceled
We're on
out,
AT&T.
I mean shared screens, my computer says 18 minutes, so.
Raw. That's not good.
We don't lose, John.
time for more.
That's classified as a performance problem.
That is a classic performance problem. All right.
Okay, well, I think we push on and I'll monitor everybody's screens and let you know when some people have made progress.
Very good. Well, what I will do is give you a little bit of a walkthrough, and hopefully, if we get some network bandwidth, everybody will get logged in. The dashboard is functionally laid out into a couple of different views. When you get a virtual appliance from Xangati, it's actually capable of providing several different views of the data. One of them is a very general view of the world that's more oriented perhaps around some of our networking heritage, and so it presents a lot of very top-end sorts of views of the world organized around protocols and a lot of the network style of interactions that are there. We also have dashboards that are keyed towards VDI, towards desktop infrastructure, as well as views that are tied towards the virtual infrastructure. And so the important thing to realize is that when you've got a Xangati appliance, it actually lets you carve up the data kind of according to different silos or different views that are relevant to a particular community. So if we look at the VDI dashboard that may come up for you at a point along here, you'll notice that it's comprised of the clients. Certainly those are the endpoints actually, and our dashboard is capable of seeing to the endpoint actually. There's of course network paths that connect those clients to the desktops back in the data center. The desktops of course actually live on hosts, and the hosts behind them there are a group of data stores, and the data stores of course have paths that connect the data stores to the hosts.
There's several other miscellaneous components of the infrastructure that we also track for virtual desktops. One of them is the idea of application servers. This might be things like XenApp servers or ThinApp servers, certainly, that are serving up those sorts of things. It could also be used for other key applications that might still reside on physical boxes, that might be doing interactions with the desktop environment and would be considered important enough to track as part of the overall infrastructure. The final column is one that's called IT servers. And this is basically to acknowledge that virtual desktops actually require quite a number of other things, right? When you've got your Active Directory servers and DNS, you have things like connection brokers, provisioning servers, security gateways. Depending on the VDI vendor of choice, there's quite a number of different kind of helper things that, that might be in there, transfer servers and all of the various sorts of things that go on in there. So there's an ability to track those things. Regardless of the object type and where they get categorized in the dashboard, what happens as soon as our dashboard is looking at infrastructure is that it begins a process of understanding each of these items. So that encompasses about 2 to 3 dozen metrics for each item that Jagan mentioned. So this is everything from CPU and CPU ready and memory things and data store things to the network and the network interactions. And we basically build a normalized profile for how each of these objects behave. And that's all automatic. Of course, you can override those. You can set your own based on best practices and things like that. But the system does that. And when things step out of the ordinary, what our system does is it will go ahead and begin to affect this health score that's at the top. The whole idea behind the health score, of course, is kind of one number to rule them, one number to bind them, and in the darkness find them, and all of that. But what happens is as the health score changes, it changes to the degree to which the overall infrastructure is impacted. And that's determined both by the number of things that are out of whack, so to speak, and how far out of whack they are. So for example, if I have out of my 13 desktops, one of them is using 5% more CPU than normal, well, that may be out of the ordinary, but it's hardly the end of the world. And you wouldn't expect to see the health score change much, if at all. And indeed, that's what happens. On the other hand, if I were to lose half of my data stores, well, that would be a really bad day, any day of the week, and you would expect to see the health score, pretty substantially impacted. The nice thing is that when something is degraded from the perspective of our product, it's very easy to find because the column headers themselves actually change color. And it's then possible to go ahead and just click directly on any one of these alerts. Now, the clever thing that Xangati does is, we have alerts, great. So it says there's a problem, and it tells you what the problem is. There's excessive network bit rate, there's too much CPU usage, whatever it is. Getting alerts out of a management system is not really a particularly new concept, right? The reality is that what Xangati does that's transformational is we actually give you a complete record of what was occurring at the time of that breakdown in the form of a recording. And this actually works very much like a DVR, or for those from across the Atlantic, a PVR recording like you'd get out of your television set, where there's actually a slider that allows you to step through this whole alert period with 1 second granularity. And I think that we had a comment about this earlier, that the perfect thing would actually be a recording that preserves literally 1 second data at the time that a particular event occurred inside the environment. And if that recording could capture all of the interactions as well as the actual metrics themselves, well, now you've really got something that enables you to have a substantially better amount of visibility into the environment.
It's just worth noting that I only see one person who has a login, so it might be worthwhile kind of helping with the eye chart. Well, 2 people. Just some of the things they're seeing and maybe explaining the difference between consumptive and interactions in the UI, because only I think we've got Ed and Bill, the only ones who can actually clearly see the screen.
I got a question.
Yes, sir.
So, are you able to see metrics like user experience, such as how long it takes them to get from the broker actually connected to their virtual desktop? Is that a metric you can actually suck in anyway, or it's more like speeds and feeds type stuff?
Let's see.
Typically, when I'm working on troubleshooting, it's like, all right, how long does it